Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to all of the audience. I'm here today to present to you what our team have done on a small scale research, which is entitled as a study on crystalline and non-crystalline silicon photovoltaic modules on angle inclination and open loop profile. So the content for this presentation is divided into 4 parts. The first one is introduction, second one is method, the third one is discussion, and lastly, the conclusions. Okay, for the introductions, our research background is focused on silicon photovoltaic. As you can see, silicon photovoltaic from previous researcher as stated on 2020, Mochlis, it said that solar PV are often famous among researchers due to marginal costs or economic value. It also agreed by Gogo Pandey as stated in 2013 due to largely anticipated market and manufacturers on silicon modules. It also contribute to the declination of value or declination of cost. And SID is famous, but in silicon photovoltaic, there are two major types, which is crystalline and non-crystalline. Okay, crystalline also got two types, polycrystalline and monocrystalline, and non-crystalline is also known as amorphous, or sometimes in different book we also state as thin films. And our research is focused on angle inclination for both sample, which is crystalline and non-crystalline. Okay, for second part is experimental sampling and research instrument, we are focused on two types. The left one is polycrystalline, crystalline class, and the right one is amorphous or in non-crystalline class. Then the specification for both crystalline and non-crystalline as stated in the table, maximum power is equal for both, and the difference is only for voltage and current. But for voltage and current, even though polycrystalline 0.5 lower than amorphous, the current for polycrystalline is higher compared to amorphous. The dimension is different. Since amorphous require larger size to contribute or to generate the same output as polycrystalline. So the data as tabulated in the table, as you can see here from the table, the left corner is the angle, which is our variable, our x-axis, and the variable here is for voltage and current. As you can see, okay, both types show an increment for both voltage and current until lastly at 90 degrees. Okay, then at 90 degrees, after that, both current and voltage for both type of silicon module drop slower slightly until the research is conducted until 120 degrees. Okay, then lastly for polycrystalline and 1.4, and amorphous is 1.7. And after we plotting from the table for graph, for voltage, as you can see here, the increment is shown for both type, but the increment for amorphous in orange line is slightly higher compared to polycrystalline. And then it's dropped again after 90 degrees. The similar situation also happened here for current. The increment for both type, but the increment for amorphous is higher compared to polycrystalline. And because of current and voltage for amorphous is higher, of course, the output power for amorphous is higher compared to polycrystalline. Okay, then there are huge gap here for 90 degrees. So what we can conclude here, okay, both polycrystalline and amorphous are dependable on degrees. Okay, dependable on degrees, and the most absorption of sunlight or generation for electricity is exactly at 90 degrees. Then after that, it will slightly lower. The output will be lower. However, amorphous, from the result, amorphous show more robust and reliable to Malaysian environment. Since the research is conducted on scorchy on peak day, okay, on peak day where the temperature and also the humidity is at peak. So amorphous, even though both of silicon modules, crystalline and crystalline, show an increment on output power, but amorphous is slightly higher compared to crystalline since it's more robust and reliable and to Malaysian environment. Okay, most of it because of the temperature and the humidity of outdoor. Okay, of outdoor. Thank you for your ears, and from me again, Jamil Beshari, as the presenter for this research.